In this video, we're going to be looking at topic 4E, alcohols, and these are the triple outcomes for organic chemistry in the IGCSE course from Edexcel. So we're going to be looking at the functional groups of alcohol and how we draw the first four alcohols, including specific isomers. We'll be looking at the reactions of ethanol in terms of oxidation by burning or by reacting with potassium dichromate. And we'll also be looking at two different ways to manufacture ethanol and comparing their advantages and disadvantages. So when we use the word alcohol commonly in the English language, what we're really using that for is typically alcoholic drinks. Now, in the scientific world, whilst that is a member of the homologous series of the alcohols, when we're looking at ethanol, the alcohols are actually a family of compounds. So when we're referring to alcoholic drinks, we're only actually referring to one single member. So we're going to use the general correct term in terms of alcohols as the full homologous series. And remember, a homologous series means that they're going to have a general formula and they are going to share properties, and looking specifically at chemical properties, and we'll see some trends in the physical properties as well. So the homologous series for alcohols have the functional group OH bonded to the carbon chain. So this time we're now not looking at a hydrocarbon. These cannot be hydrocarbons because they contain oxygens, and remember, hydrocarbons contain only carbon and hydrogen. So whilst they are an organic substance and they are a homologous series, be very careful not to use the word hydrocarbon in any of your answers. Now, the simplest alcohols are the first four, with carbon chains going from 1 up to 4, and they are methanol, ethanol, propan 1-ol, and butan 1-ol. Now, you'll notice that you can see that there's a number here, and that is going to become an important number later on when we talk about isomers. But we're just going to focus on these four for the moment, and as with all the other homologous series that we've covered, you need to know the names, the molecular formula, the structural formula, and the displayed formula for the first four members in this series. So let's start off with the most simple alcohol. So this is going to be methanol, and notice that we have all of our substances having the same surname as we've seen when we looked at the alkanes and the alkenes. They all have the same ending, and we think of that like the family name. So we have meth meaning one and anol telling us it's an alcohol. Now what I'm going to do is I'm going to jump over to the displayed formula as we've done previously, because it's easier to then work our way back. So if we have methanol, we have one carbon, and then we have an oxygen and a hydrogen bonded. Now, when you're drawing the displayed formula, you should draw out every single bond, including the bond between the oxygen and the hydrogen. It's a bad habit to fall into writing OH. Sometimes it is accepted in a mark scheme, but not always. So to make sure that you're covering yourself, I would always draw out all of the bonds. And then we just fill in the remaining hydrogens around to make sure that my carbon has 3 other hydrogens and the oxygen giving us a total of 4 bonds. Then I can draw out my structural, so I break it down into my smaller chunks. So I have CH3OH, and then my molecular formula is going to just combine everything to tell me how many carbons, hydrogens, and oxygens I have. So I have CH4O, and that's the first. That's methanol. Then we're going to move on to ethanol. Now, this is the one that comes up most commonly in exams, and usually when you're talking about any reactions in an exam, you're going to focus on ethanol. So this is the most important one to be able to draw. So eth we know means 2, so I've got 2 carbons in a row. I'm going to keep my OH in the same position each time at the end, and then I'm going to add in all my hydrogens, making sure that every carbon has 4 bonds in total. Then I move to my structural, so I have CH3, CH2, OH, and of course my molecular, just counting everything up, and it gives me 2 carbons, 6 hydrogens, and 1 oxygen. So that is ethanol, our second member. Now we're going to look at the third member of the group, and we're going to focus on the most simple, which is called propan-1-ol. Now, the reason that we use the 1 here is that we need to know what carbon the OH group is bonded to, because similar to the position of the double bond in an alkene, depending on where the OH group is attached will be a different isomer of these compounds. So if we stick with just the simplest, where we're always going to have it on carbon number 1, we will look at some isomers in just a few minutes. So for propan-1-ol, I'm going to draw out my 3 carbons. Again, I'm going to keep my OH right at the end, and I'm going to fill in the remaining hydrogens, ensuring I've got 4 bonds to every carbon, and then breaking that down is going to give us CH3, CH2, CH2, OH, and my molecular formula, I've got 3 carbons, 8 hydrogens, and 1 oxygen. And then the last one that you have to know is butan-1-ol. Again, the 1 telling us that the OH is connected to carbon number 1. So I've got my 4 carbons in a row with my OH group, and then of course filling in all of my hydrogens, making it very clear where the bonds are and what they are connected to. And then breaking that down gives me CH3, CH2, 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 OH, and counting them up, it gives me 4 carbons, 10 hydrogens, and 1 oxygen. So there we can see the structures and the formulas drawn out just a little bit clearer. Each time our OH showing all of the bonds and always connected to the last carbon in the chain. Now, when we name an alcohol, it's similar to when we name an alkane or an alkene, but in this time we have to be very specific about the position of the functional group. So we can break the name of an alcohol down into 4 parts. So if we have butan-1-ol, we break it down into, first of all, the but tells us I have 4 carbons. The an, or the an, is to tell us it's saturated, which means it's all single bonds. Remember, like an alkane would be saturated. If this was an en, it would tell me there's a double bond. The 1 is the position of the functional group, so the OH telling us that's on carbon number 1, and the OL at the end tells us that we have this OH functional group. So butan-1-ol tells us it's an alcohol, the OH group's on carbon number 1, there are 4 carbons, and it's all saturated. So we're getting all that information just from one short name of an alcohol, and we can apply the same logic to any of the alcohols. Now, when we're looking at isomers of alcohols at IGCSE, we're only going to be focusing on the position of the functional group. Whilst you can change the isomer into branches and have 2-methyl or 3-methyl, similar to what we saw in the alkanes or alkenes, we're just going to keep it very simple and just look at the position of the functional group. So if we look at butanol, where we know that we have got 4 carbons, we can actually have the OH group on different carbons, giving us different isomers. So if we draw out the 4 carbons in a row, I can have my OH group on the very end of the chain, and then I add in all of my hydrogens. And when we're wanting to number the carbons, we want to make sure, similar to a double bond, that the OH group is on the lowest possible number. So here we would be numbering 1, 2, 3, and 4. So this would be the one that we've already met, and this is butan-1-ol. However, we could always put the OH here, and then I add in my hydrogens, again making sure that every carbon has 4 bonds, and we have all single bonds. And this time I'm still going to number from right to left, but this time my OH group is on carbon number 2, so this would be butan-2-ol. So these are my two possible isomers with a 4-carbon chain. I can either have butan 1-ol or butan 2-ol. Now, some of you might say, well, what if we put the OH group on this carbon? Wouldn't that be butan 3-ol? And the answer to that question would be no. If we put the OH group on this carbon where the arrow is pointing, what we would do is we would now number them from left to right as opposed to right to left. Remember, we always want the functional group to be on the lowest possible number. And we can number the carbons in any direction to make sure that that number is as low as possible. So butan 3-ol is not an isomer. So please make sure that you do remember that for an exam. And there you can see them drawn out like this. Now, as I said, you can draw an OH group like that without having the extra bond, but it's best just to always draw out that bond just in case. If you do draw it like that, you have to make sure on something like butan 2-ol that it is clear that the bond is to the oxygen and doesn't look like it's going to the hydrogen. So be very, very clear on that. Now we're going to look at some of the reactions of alcohols. Now, because alcohols are carbon and hydrogen based with a little bit of oxygen, they do burn in the same way as hydrocarbons do. So when we burn alcohols, we are going to make carbon dioxide and water. And this is an example of the equation to show the combustion of ethanol. Now, ethanol, and that's the alcohol that we're going to be putting our focus on moving forward, ethanol is a biofuel. And this means it is a fuel that is made from biological sources. Now remember, a fuel just means that when you burn it, it gives out heat energy. And ethanol can come from natural sources. And we're going to look at the production of ethanol in just a few minutes. So mixtures of petrol and biofuels are being used more and more often in countries like Brazil, where we don't actually have a lot of access to fossil fuels. So we know from what we learned about crude oil that petrol is one of the fractions from fractional distillation. Now, when we don't have easy access to this, like in countries like South America or potentially countries in Oceania where there are islands and they're not very easy to get a hold of fossil fuels, then we can use things like biofuels because it helps reduce this dependence on non-renewable fuels. And it actually helps us elongate the lifespan of the fossil fuels. So we want to make sure that we're not going to run out. Of course, we know we will, but the longer we can put that off, the better. So biofuels are a nice alternative for that. Now, that's what happens when we burn the ethanol, so when we ignite it and add a flame. We can also have the ethanol reacting with the oxygen just in the atmosphere and being left open to the elements as opposed to actually burning it. Now, this process takes a little bit longer. It is slower when it's at room temperature, but the alcohols can oxidize into a carboxylic acid, and that's something that you will look at in topic 4F. You'll go into some more details about that, but you can see that a carboxylic acid is similar in structure to an alcohol. It just has this extra carbon to oxygen double bond here. So we can go from the alcohol to the carboxylic acid using the help of microorganisms or bacteria in the atmosphere. And if the ethanol is left open in the air, it turns sour because it forms vinegar. Vinegar is an aqueous solution of ethanoic acid. And as I said, we'll cover that in a bit more detail in topic 4F. Now, the usual way to oxidize an alcohol without just leaving it simply to the elements is to use something known as an oxidizing agent. And you will have covered this back when you did the reactivity series. And in this case, we're looking at something known as acidified potassium dichromate 6. Now, you don't need to know too much about this at the moment. All you need to know is it's a potassium dichromate substance that's had some sulfuric acid into it. And this allows a redox reaction to happen. And what we see is we have this lovely orange colour at the start. We then put it into hot water, and then we get a green colour and that tells us that we've had an oxidation reaction. So we go from orange to green. It's extremely important that you do remember those colour changes because that does come up in exams. So when the ethanoic acid is formed, as we said, we get this colour change, and this happens because we have the presence of these chromium 3+ ions. And this is formed when the potassium dichromate gets reduced. So remember, an oxidizing agent itself is being reduced because oxidation has to happen at the same time as the reduction. So if we're oxidizing the alcohol to the carboxylic acid, our potassium dichromate is being reduced into the chromium ions. You will go into a lot more detail about this in A-level and year 12. What you need to know for IGCSE is the name of the reagent and the colour change, and that is more than enough. Now, when we're looking at the production of alcohol, there are two possible ways that we can do this. We need to know both methods and also be able to compare and contrast the methods. So the first way is to use fermentation, and you've actually probably talked about this in biology, but we go into more the chemistry of it in terms of the conditions and the actual equation. So if we take yeast, which is a microorganism, and we add it into sugar or even into starch, and we leave it for a few days in warm and anaerobic conditions. So anaerobic meaning a lack of oxygen. What's going to happen is we're going to see fermentation occurring. This is because the enzymes that are in the yeast are going to convert the sugar into carbon dioxide and ethanol. So we're taking this sugar or this glucose, we are fermenting it, and we are forming carbon dioxide gas and ethanol. Now, one thing with this particular reaction is the temperature cannot be too high, or the enzymes in the yeast are going to denature. And if you remember from biology, denaturing enzymes means to change their shape so that they now no longer work, and that's an irreversible process. So we don't want the temperature to be too high. It cannot then also be too low or the reaction doesn't happen. So we have to find the optimum temperature. So the perfect middle ground between no reaction and denaturing. And the optimum temperature is between 30 and 40 degrees Celsius. So what you should be able to do is you should be able to write out this particular equation. So going from the glucose, which is our sugar, and forming 2 moles of ethanol and 2 moles of carbon dioxide. You should be able to identify the starting materials. So the sugar comes from sugarcane, which is a natural source, that's a plant that can be grown. We're at 30 degrees. Our catalyst in this case is an enzyme that's in yeast, and it's anaerobic, which we've said means we're doing this with a lack of oxygen. We have to have that in order for the yeast to respire anaerobically to allow this reaction to happen. Now, the second way that we can produce alcohol is we can use hydration. So the hydration reaction uses an alkene, and we use a phosphoric acid catalyst. Now, hydration, you may be able to work it out, is an addition reaction where we add some water across a double bond, so across the ethene, and then we form ethanol. And the best thing about this is we get no byproducts. So when we do fermentation, we do make that carbon dioxide as a waste product. Here, we have no extra product. And the best thing about this is it then gives us a higher percentage yield. So you'll have covered percentage yield back when you did the calculations, and you'll know that for any reaction, we want to get the highest possible percentage yield. So the good thing with hydration is it does give us that. So a small proportion of the ethene is going to react to make the ethanol, and anything that doesn't react is then recycled back to the start of the process. The ethanol that forms, as opposed to being a gas the way ethene is, then condenses and then it is collected and sent off to be used for whichever methods or whichever use it's going to be needed for. So again, you need to be able to write out the equation for this. So we have ethene, so our 2 carbons with our double bond, adding in the water. Notice that the water is in the form of a gas. This is done at quite high temperatures. So it is, in theory, it's steam. And then we form our ethanol as a gas, and it is then condensed and collected as a liquid. So the temperature for this is about 300 degrees Celsius. There is a pressure of 60 to 70 atmospheres, so we need a much higher pressure for this, and we need our phosphoric acid catalyst, which is the H3PO4. Now, when we compare the production methods, we have to look at the positives and the negatives of both of them. So if we start by looking at the use of the resources, fermentation uses renewable resources. We can grow the sugar, and we can grow the corn or any other starchy materials that we're going to get the sugar from. Hydration, on the other hand, uses finite non-renewable resources. We need crude oil in order for this to work. And the problem with this is as soon as all the oil is consumed, we can't do this process anymore. Moving on to the type of process, fermentation is what we call a batch process, meaning we set it up, we leave it for a few days, we then remove the batch, and then we repeat with a new batch. The problem with this is it's quite inefficient. We don't want to have to be making new batches every couple of days. Comparing this to the hydration is a continuous flow process. So we are constantly passing the reactants over our phosphoric acid catalyst, and we're constantly recycling anything that's not used and going back and continuously doing it. So this is a much more efficient process. In terms of rate of reaction, fermentation is quite slow. As we said, it takes several days, whereas the hydration is a very fast reaction. Fermentation produces a poorer quality of product. It typically needs further processing, and we also make this additional product of carbon dioxide, whereas the hydration produces much purer ethanol that we don't really need to process. One of the big things is the reaction conditions. For fermentation, we use atmospheric pressure and very gentle temperatures, so our energy costs are quite low. Whereas hydration needs very high temperatures and pressures, so it requires quite a high input of energy, and that's a major disadvantage. So any company that's wanting to produce ethanol is going to have to weigh up their advantages and disadvantages and figure out what works best for them. For some companies, fermentation is better because they have better access to sugar, but for others, they might need it quicker and a much purer product, so they may choose to use hydration. What's important is that you can compare and contrast both methods in an exam. So let's finish off by looking at some past paper questions. What you will find is that alcohols are fairly new to the specification. Whilst they were in the old spec, they really only talked about the fermentation and hydration process. You won't find any questions on carboxylic acids because this is new for the new specification. So just be aware of that, and if you do want to practice those oxidation questions, you can ask your teacher and they'll be able to find you some. So in this question, we're given a displayed formula and we're asked to give the molecular formula of the compound. Now that's nice and simple, it's just counting. So we have 3 carbons, we have 8 hydrogens and 1 oxygen. Now a trap that some people fall into would be to write C3H7OH. Now sometimes you may see that written out, and whilst that is a formula for this propanol, it's not the correct molecular formula. Sometimes you'll write out the OH so that we know that this is an alcohol, but a molecular formula doesn't take into account any functional groups. It's simply how many carbons, how many hydrogens, how many oxygens. So that would not be accepted. So just be aware. The student then describes this compound as a saturated hydrocarbon. Explain whether the student is correct, and we have 3 marks here. So we're going to break it down into 2 parts. We have the saturated and then we have the hydrocarbon. So first of all, yes, it is saturated. And the reason why it is saturated, because it has all single bonds. Or you could say no double bonds. And then no, it is not a hydrocarbon, as oxygen is present, and then we should state what is a hydrocarbon. Hydrocarbons contain only hydrogen and carbon, and that's where you get your 3 marks. Most people would probably stop after the second bullet point, but remember it's a 3-mark question, so you are expected to be giving 3 different points here. And there you can see in the mark scheme, we're rejecting our C3H7OH, and for our mark point 3, we're actually specifying that a hydrocarbon contains only hydrogen and carbon. The second past paper question is looking at the manufacturing. So we've got 2 different reactions. So the first one is our hydration, and the second one is our fermentation. So part A, identify one raw material that could be used as a source of C6H12O6. Now we can't say glucose, because whilst that is glucose, that's not what the question is asking. The question is asking is a source of glucose. So we're just going to keep it nice and simple, and we're simply going to say sugar or sugar cane, and that would get you the mark. Reaction 2 uses a catalyst called zymase, which is present in yeast, so that's our enzyme. We want to identify the catalyst that is in reaction 1. So the catalyst for hydration was phosphoric acid. And you can either give the name or you can give H3PO4, because it just says identify, it doesn't say anything about the name or the formula. And in both reactions, it's important to control the temperature. For reaction 2, we want to say why is it important to keep it below 35, and that is to stop the enzyme from being denatured. Remember, we don't want the enzyme to denature, because that changes the shape of the active site and it can destroy or kill the enzyme, and then our reaction doesn't happen. And then lastly, a manufacturing company plans to build a factory to produce ethanol on a large scale. The factory will be near an oil field, and the ethanol will be used as a solvent for perfume. Suggest why the company would use reaction 1 rather than reaction 2. So why will this company want to use the hydration method instead of fermentation for 3 marks? Now, one thing to take from this is that they're near an oil field. So the ethene is easily sourced from the nearby oil field. So that works as a benefit for this company. Because they're near the oil field, they can easily get the ethene. Then we want to think of some of the other important things that we discussed previously about the benefits for hydration. One main thing is that we get a higher percentage yield, or we can phrase that as we get a purer product. And also, the reaction is faster. So we know that this reaction is much faster than the fermentation, because that can take a couple of days. We could also potentially say that we would need to have land in order to make the sugarcane, or sugarcane needs specific conditions to be able to grow that this company may not be able to do, or the fact that the hydration reaction is continuous. There's a number of different responses that you could give here, and you can get any of them for 3 marks. So we can have all of the information that we need. And the mark scheme, looking specifically at part B, where there's 6 possible points and you just need to get 3 of them. So that's everything for topic 4E, alcohols, for the triple content. As I said, there may not be a massive amount of past paper questions on this, so you might want to check with your teacher if they can source you some either from A-level or from another exam board other than Edexcel. If you do have any questions, please feel free to leave a comment below, and we hope to see you back.